Hi, everybody. So today we're going to be talking about 10.4, which is compound events. So our learning target is going to be, I will be able to find the probability of a compound event using sample spaces and the total number of possible outcomes. So right now, make sure that you have this written down in your composition notebook. And remember, you need to be taking notes on every single slide. Okay, so our first vocabulary word is going to be sample space. And what a sample space is it's the set of all possible outcomes of one or more events. Okay, so that's a sample space. It's a set of all possible outcomes. So we're going to take a peek at that today. Okay, so finding a sample space. This question asks you randomly choose a crust and style of pizza. Find the sample space. How many different pizzas are possible? And it wants us to use a tree diagram. So I'm going to show you how to do this. So please follow along and write what I'm writing. So if we want to find the whole sample space, well, it looks like we have two different crusts we could choose from. Okay, we have two different crusts. So I'm going to write down, oh no, one sec. Going to write down crust. Okay, and then we have style, and then we have outcome. Okay, so the different types of crust we have thin crust, and then the styles that you could do it, there's 4 different styles. So you could either have it as Hawaiian, you could have it as Mexican, you could have it as pepperoni, or you could have veggie. Okay? Now the outcomes. So what that means is you could have a thin crust Hawaiian. Okay, so look, it's like a tree. That's a branch to there, that's a branch to there. So it's a thin Hawaiian crust. This would be a thin crust Mexican. So a thin crust Mexican style pizza. This would be a thin crust pepperoni pizza. And this would be a thin crust veggie pizza. So those are all the different ways that you could have a thin crust pizza. Now let's do the other type of crust, which is a stuffed crust. Okay, so the options styles are the same. It's Hawaiian, Mexican, pepperoni, and veggie. And then let's use our tree diagram to figure out the outcome. So we could have a stuffed Hawaiian, so stuffed crust Hawaiian. We could have a stuffed crust Mexican style pizza. We could have a stuffed crust pepperoni pizza, and I'm going to abbreviate that to just pep. Or we could have a stuffed crust veggie pizza. Stuffed crust veggie. Okay, so it asked me to find the sample space. So this is the sample space right here. All of these outcomes, these are the sample spaces because this is all the different options you could have given the different crust styles and the style of pizza. So how many different pizzas are possible? Well, let's count them out. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 possible pizzas. All right, make sure you have this down and let's move on to the next example. So this is a key idea and it's the fundamental counting principle. So I would like you to write this down. So what this means is, here's the formal probability language. An event M has M possible outcomes. An event N has N possible outcomes. The total number of outcomes of event M followed by event N is M times N. So this is going to be the fundamental counting principle. So make sure you have this down in your notes, write this down, and when you're ready, click play. Okay, we're going to be finding the total number of possible outcomes. So this is how many different outfits can you make from the t-shirts, jeans, and shoes in the closet? Well, here's what we're going to do. I'm going to create different events. So my first event, which is event 1, is going to be choosing a t-shirt with, or choosing a t-shirt has. And let's see how many t-shirts are there. 1, 2, 3, 4, 5, 6, 7. There's 7 t-shirts. So I'm going to write has 7 possible outcomes. Then my second event, so event 2, is going to be choosing jeans. And that has how many possible outcomes? Well, we have 1 pair, 2 pair, 3 pair, 4 pair. Has 4 possible outcomes. And then event 3 is choosing shoes. And that has, well, we have 1 pair of shoes, 2 pairs of shoes, 3 pairs of shoes. That has 3 possible outcomes. Okay, so now we're going to go back to our fundamental counting principle, which you just looked at on this. And obviously, when you dress yourself, you put on a pair of jeans, you put on a shirt, you put on shoes. There's different combinations, though, in how you could do that. You could be wearing the green pants, the yellow shirt, and the green shoes. But then another time, you could be wearing the red pants, the yellow shirt, and the green shoes. So there's a lot of different combinations. So that's when we're going to use our fundamental counting principle. And that says you're going to take the possible outcomes of each of these events and multiply them together. So since we have 3 events, we're going to multiply 7, because 7 possible outcomes for event 1, times 3, or times 4, because there's 4 possible outcomes for event 2, times 3, because there's 3 possible outcomes for event 3. And if I multiply those together, I'm going to get 84. So that means there are 84 different outfits that you could create from this closet. 84 different outfits. That's kind of a lot of outfits. Okay, make sure you got this down, and then we're going to move on to the next one. Okay, finding the probability of a compound event. So it says you flip 3 nickels. What is the probability of flipping 2 heads and 1 tails? So let's just remind ourselves. A nickel, one side is tails, one side is heads. And we're going to let T equals tails and H equal heads, okay? And what I'm going to do is I'm going to make a tree diagram. So similar to that pizza problem, we're going to make a tree diagram. So the first time I flip a coin, what are my 2 options? It's either going to be a heads or a tails, right? Those are my 2 options. Okay, so let's say the second time I flip it. If I flipped a heads first, what are my 2 options for flipping the second coin? Well, it's either going to be a heads or a tails, right? Same with this one. It's either going to be a heads or a tails. Now, the third time I flip the coin, well, again, there's going to be the same 2 options, either heads or tails, heads or tails, heads or tails, heads or tails. Now, this tree diagram just is going to tell me every single option. So this tree diagram, so if you look here, the HHH, so HHH up here, I'm going to write it down, HHH. That means that you flipped 3 heads. So the first time you flipped it was a head, second time it was a head, third time it was a head. This one, HHT, HHT, that means you flipped 2 heads and then a tail. And then let's go down to this one, heads, tails, heads, heads, tails, heads. That means you flipped a heads, flipped a tails, flips a heads. Then HTT, that means heads, tails, tails. So you're going to do this for the bottom one as well. So it's going to be tails, heads, heads. And what I'm doing right now to get this is I'm just following the tree diagram. So this says tails, heads, heads. So then I know that this one is tails, heads, heads. Okay. And I'm just doing that for all of them. So then it's tails, heads, tails, tails, heads, tails, 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 heads, and then tails, tails, tails. Okay, so that's the nice thing about the tree diagrams is you can kind of see all the different outcomes for a compound event, which means there's more, you're flipping a coin 3 times. You're not just flipping it 1 time. So it says, what is the probability of flipping 2 heads and 1 tails? So let's go through and circle the ones that have 2 heads and 1 tails. Well, this has 2 heads, 1 tail. This has 2 heads, 1 tail. That doesn't. This has 2 heads, 1 tail. And that's about it. So now we're going to go back to our earlier sections of chapter 10, which is finding the probability of an event. Okay. So my event for this is going to be 2 heads and 1 tail. Okay. Because that's what it tells me it wants me to find. Now, we need to figure out how many different ways could you get two heads and one tails? Well, 1, 2, 3. Okay, so there's 3 possible ways over the total amount of outcomes you could have. So that's 1, 2, 3, 4, 5, 6, 7, 8, because there's 8 different options. All right, and now remember to find the probability. In your calculator, you just do 3 divided by 8, and that should give you a decimal. If you turn that decimal to a percent, you should get 37.5%. So the probability of flipping 2 heads and 1 tails is 37.5%. All right, and if you're at home right now, you could test it out yourself and be flipping some nickels right now to just test it out and kind of get to know probability. But that is the main gist of 10.4, which is compound events. Make sure you have all these notes down in your notebook, and we'll get started on the big idea soon. Thanks for watching.